In this video tutorial, we will demonstrate how virtual machine instances can be migrated from VMware environments to KVM-based infrastructure using Apache CloudStack. We will demonstrate both supported migration approaches, using an existing VMware cluster already managed by CloudStack and connecting to an external VMware cluster through vCenter. VMware clusters can be managed in two ways within CloudStack. They can be injected as existing clusters and operated directly as part of the CloudStack infrastructure, or they can be connected externally through vCenter. In both cases, CloudStack discovers the VMware resources and virtual machines and makes them available for migration through the same APIs and user interface. Apache CloudStack is multi-hypervisor by design. This allows VMware and KVM environments to coexist within the same control plane. Workloads that are not yet supported on KVM or depend on specific hardware certifications can continue running on VMware. The source environment consists of VMware-based virtual machine instances managed either as an existing cluster inside CloudStack or as an external cluster connected through vCenter. The target environment is a CloudStack-managed KVM cluster where selected workloads will be migrated. Before migrating virtual machine instances from VMware to KVM, the KVM hosts must be prepared to support disk conversion and workload import. For detailed preparation steps, refer to the official CloudStack documentation linked in the video description. Before executing migrations, it's important to consider workload behavior and downtime requirements. In this demonstration, we will start by reviewing the source environment in VMware vSphere. The vSphere environment is organized as an isolated silo for a specific department identified here as Department 01 or DP01. Within this department silo, there are 4 virtual machine instances supporting 3 distinct projects. The ERP project consists of 2 virtual machine instances, one supporting the application layer and one supporting the database layer. In addition, there is a web project with a single virtual machine instance and an Active Directory project with 1 virtual machine instance providing directory services. Each project operates on its own dedicated network with isolation enforced through VLAN segmentation. Next, we move to Apache CloudStack to reflect this same organizational structure. A dedicated subdomain named DP01 is created. Within this subdomain, 2 separate accounts are defined. One for production workloads and one for development workloads. Within this subdomain, a single production account is defined. Within the production account, 3 projects are created to organize the workloads by application domain: ERP, Web, and Active Directory. For each project, a dedicated network is created, providing network-level isolation consistent with the original VMware environment. In addition, dedicated compute offerings are defined to reflect the CPU and memory characteristics of the existing virtual machine instances. This approach mirrors the organizational boundaries of the existing VMware environment, while enabling clear separation, governance, and independent lifecycle management of workloads within CloudStack. Next, we will demonstrate the migration from an external VMware cluster connected through vCenter. In the CloudStack user interface, we begin by selecting the web project where the target workload will be deployed. From the side menu, we navigate to Tools and then select Import-Export Instances. In the Source Hypervisor section, we ensure that VMware is selected. We then choose the option Migrate Existing Instances to KVM. In the Destination section, we select the appropriate KVM cluster and choose the external mode. We provide the vCenter IP address, select the appropriate data center, enter the VMware credentials, and click List VMware Instances. The available VMware virtual machine instances are then displayed. For this demonstration, we select the Portal Linux 01 virtual machine instance and proceed by clicking Import Instance. A configuration form is presented. We complete the required fields as demonstrated, including name, project, compute offering, and network selection, and then initiate the import process. By navigating to Import VM tasks, we can monitor the status of the migration. In the vCenter interface, the export activity can also be observed. Once the process is completed, the task status is shown as successful in the CloudStack interface. We then log out and log back in as a regular user. After selecting the appropriate project, we navigate to Compute Instances. The imported instance is now visible. We power it on, and once it's running, we access the console. At this point, we can confirm that the converted virtual machine instance is successfully running on the KVM infrastructure. Now, we'll demonstrate the migration of a virtual machine from an existing VMware cluster into CloudStack using KVM as the target hypervisor. Inside the CloudStack user interface, we begin by selecting the AD project, which is where the migrated workload will be deployed. From the left-hand navigation menu, we go to Tools, and then select Import-Export Instances. In the Source Hypervisor section, we confirm that VMware is selected. Next, we choose the option Migrate Existing Instances to KVM. In the Destination configuration, we select the appropriate KVM cluster that will host the migrated workload. We then choose the relevant zone, specify the VMware Data Center and vCenter, and click List VMware Instances. CloudStack now queries the VMware environment and displays the available virtual machine instances. For this demonstration, we select the virtual machine instance add-win01 and proceed by clicking Import Instance. At this point, the workflow is similar to the previous example. Once the configuration is completed, we initiate the import process. CloudStack orchestrates the migration in the background, exporting the VM from VMware, converting the disk format, and registering the instance in the KVM cluster. When the task status shows successful, the migration process is complete. Now we log in as a regular user. After selecting the appropriate project, we navigate to Compute, Instances. The imported virtual machine instance is now visible. We power it on. Once the instance is running, we access the console to confirm that the operating system boots successfully and that the workload is operational. This completes the migration from an existing VMware cluster into CloudStack using a structured and controlled process. In some environments, not every workload can be immediately migrated to KVM. Certain virtual machine instances may need to remain on VMware due to hardware certification requirements, vendor support constraints, regulatory compliance, or application-level dependencies that mandate a specific hypervisor stack. In these cases, CloudStack provides the ability to ingest and manage existing VMware workloads under a unified control plane without performing a hypervisor migration. To demonstrate this capability, we will ingest two ERP virtual machine instances. We begin by selecting the ERP project, which is where these workloads will be managed. From the left-hand navigation menu, we navigate to Tools and then select Import-Export Instances. In the Source Hypervisor section, we confirm that VMware is selected. Next, we choose the option Manage/Unmanage Existing Instances. In the Destination configuration, we select the appropriate zone, pod, and the relevant VMware cluster. CloudStack now queries the selected cluster and displays a list of unmanaged instances on the left-hand side. We select the ERP virtual machine instance that we want CloudStack to manage and click Import Instance. At this stage, the workflow is similar to the previous examples. We review and confirm the configuration parameters, ensuring that the instance is correctly associated with the selected project and infrastructure components. Once the import process completes, the ERP workload is now visible within CloudStack and can be managed through the CloudStack interface, even though it continues to run on VMware. This approach allows organizations to operate hybrid environments, where selected workloads remain on VMware while others are migrated to KVM, all under a single unified control plane.